Hi, my name is Jeremy Greer. I'm one of the co-founders at Oumi, and today I'm going to talk to you about our HallOumi model, our first step towards building more reliable large language models. So first, I have to talk about what is a hallucination. Hallucinations are one of the most important challenges in generative AI for both commercial and personal applications. And we have some examples here to talk through. There's been cases where lawyers have gotten in trouble for using evidence from ChatGPT where it created six fake cases. The airline Air Canada had to honor a refund policy that was completely made up by its AI agent. And we've also had AI suggesting users should make glue pizza and eat rocks. So, why does this happen? Ultimately, generative models have been trained to produce outputs that are likely, but not true. Now, this still can be useful in the right hands, but we have to be able to trust these things if we're going to be able to use them more broadly. So, where does that trust start? So, that trust starts with verifying what they say. So, when I say verify, I specifically mean for every statement being produced by the model, we need to understand, is it true or not? And just understanding if it's true, it's not enough. We also have to identify the evidence that supports whether it's true or not, because we need to be able to reason about whether or not that truthfulness is even correct. And lastly, we also need traceability. So we might have evidence, but we need it to be easy for humans to find that evidence and verify it themselves. Now, ultimately, these three aspects are what Halloumi does. So, Halloumi takes in a context, a document of some sort, and it takes in a response, a set of claims, and it splits out the response into individual claims, verifies each one, provides a confidence score for each verification, a rationale explaining why this statement is supported or not, and has per line citations that enable you as a human to go and verify okay, the fox rigged the race. In this sentence, it was only stated that the fox would set the course. Therefore, this rationale makes sense and this claim makes sense. Ultimately, this is what Halloumi provides per sentence verification with sentence level citations and human readable explanations. When given context and AI generated response, it can identify each claims that are supported or not supported, tell you where the evidence is from that ground truth you gave it, and an explanation describing why. Now, what does this look like in action? Well, we have a demo at umi.ai/halloumi-demo that you can try. So let's go there now. So here is the opening page of the demo, and let's go ahead and get started. We have a toy example here of the tortoise and the hare, which is a very common storybook example that many people know about. For those unaware, effectively, the tortoise and the hare go for a race, and the tortoise winds up winning because the hare runs faster but falls asleep, and then the tortoise catches up, goes past it, and winds up winning the race because the hare fell asleep. So, with that in mind, we have our context, which is the story. So here are our claims. We have the tortoise won the race, which is true. We have both animals slept, which in this version of the story is true. The tortoise is sleeping at the end, and the hare falls asleep earlier on in the race. The hare ran faster than the tortoise. This is an interesting one because hypothetically the hare ran faster, but it's not explicitly stated, and the tortoise winds up winning the race. So we'll see what judgment Halloumi winds up making. And then lastly, the one statement that is a complete lie, the fox rigged the race. In this example, the only statement is that it was agreed that the fox should choose the course and decide the end. So nowhere does it say that the fox rigged the race, or nor does it really imply it. Now, let's go ahead and click Verify Claims, and it should only take a few seconds to come up. And here we have our list. So first, the tortoise won the race, and we can see it's highlighting the examples of the race came and the tortoise and the hare started together. The tortoise never stopped for a moment, walking slowly but steadily right to the end of the course. And then lastly, when the hare reached the end, he saw the tortoise there already sleeping comfortably after her effort. So we can see Halloumi provides a support value of this is a 97% chance of being supported, and this is a 97% confidence interval. In terms of Halloumi being confident that this is supported, and a 3% confidence that it's unsupported. And it gives a rationale, which is as I stated before. There's a race between the two, and the tortoise reached the end before the hare who was still running, and provides those citations I mentioned earlier. And it does this for every claim. Both animals slept. It identifies both lines where the tortoise and the hare were sleeping. The hare ran faster than the tortoise. This one is borderline. It's 48% supported, 51% unsupported. And the response kind of coincides with this. It states that the hare ran fast, but also states that the tortoise walked steadily. And so this implies this hare's speed was not enough to overcome the tortoise's steady pace. Was the hare faster than the tortoise? Hard to say based on the evidence and the context. And then lastly, heavily unsupported, the fox rigged the race. The text states that the fox chose the course and decided the end, but it does not imply that the fox intentionally rigged the race. The fox's role was simply to decide the rules of the race. So, as we can see, Halloumi is able to break down the response into individual claims, validate each claim as being supported or unsupported, and provide direct evidence for or against that support status, an explanation, and a confidence interval to its own prediction. Now, how good is it? Well, according to our evaluations, it seems to outperform most large language models in this similar task. What is this evaluation? Well, after looking at a number of benchmarks, we found many of these hallucination benchmarks were unreliable for two reasons. One is the examples aren't really aligned with use cases because they were just extracted from large documents without sufficient context. Second, the many samples are mislabeled. To evaluate Halloumi properly, we needed to develop a benchmark that really reflects this problem space. So, this benchmark includes documents across a broad spectrum of topics with varying levels of information density, requests corresponding to different forms of summarization and QA, and AI generated responses for these requests across the aforementioned documents. We linked to this benchmark and how we created it inside of Hugging Face. The benchmark consists of 2,089 prompts, each containing a document, a response, and a label. The labels were generated using Llama 405B with a single shot prompt example and human in the loop. To validate their accuracy, we sampled 760 claims, had them annotated by a linguistic expert, and ensured a high level of agreement with the benchmark labels of 94.5%. Ultimately, these are the results that we found across some many open and closed models, and Halloumi drastically outperforms them. Halloumi is open source, was trained using Oumi with datasets synthesized using Oumi. The generative and classifier models are both available on Hugging Face for free, and the datasets are also on Hugging Face. In addition, the process for creating these datasets is outlined on each Hugging Face page, along with appropriate licensing. And the recipe to train Halloumi is located on our GitHub. Looking at the GitHub page for the training recipe, We can scroll down and see the steps involved: pip install Oumi and running the training steps. Lastly, if you would like to host a version of the model yourself and host the web UI that we have on our website, we have created a demo for that as well on Oumi-AI HallOumi demo in GitHub. Here is a link to the demo in GitHub, as well as the instructions on how to set up the repository but run it locally if you have a GPU. In addition, we also have a video guide showcasing how you can train your own Halloumi model using Llama 4, which I'll link in the description. Thank you for watching. If you'd like to learn more about the Oumi platform, feel free to visit our website or visit our GitHub. If these resources were useful to you, feel free to give us a star on GitHub. We appreciate it. If you'd like to build interesting AI with others using Oumi, feel free to join our Discord. Thank you, and I'll see you next time.